Femap 2306 introduces extensive support for Simcenter Nastran's Rotor Dynamics solution sequence, Solution 414, which can be used to execute different analysis types, including maneuvers, normal modes, complex modes, harmonic response, and transient analysis of rotating structures. For rotor dynamics, 3 new element property types are supported. The first new supported element property type is the gear element, used for connecting rotors, and this property is written out to the gear card. The Fourier element couples a node on the 3D part of the model to a target node on the 2D Fourier axisymmetric portion of the model, writing to the FOU3 Nastran card. Rotor Dynamics supports the Nastran pBear2 property type. Users can define bearings with constant stiffness, mass, and damping matrices, or stiffness, mass, and damping matrices with rotational speed, time, or frequency-dependent values. In addition to the new property types, there are 3 new entity types available for rotor dynamics. The model info tree has a new rotor dynamics branch that contains the new entity types: XY plot definition, bearing speed, and rotational speed. First, XY plot definition can be used to create an out-MGT entry, which allows users to generate nodal, elemental, and/or advanced XY plots for various types of rotor dynamics runs. These XY plots will appear as Femap functions, which can be plotted in the charting pane after results have been loaded. Next is bearing speed, which maps to the SPEBE2 entry and allows users to select the rotors Simcenter Nastran should use to retrieve the correct speed for bearing elements, which are dependent on rotational speed. Finally, rotational speed is used to specify rotation speeds in 3 different forms: as individual rotation speeds, which writes an omega entry; as a linear sweep with equally spaced speeds, which writes omega 1, or as a logarithmic sweep, which writes omega 2. Rotor Dynamics Solution 414 has 5 new analysis types. Solution 414-101, Maneuvers, is a linear static analysis with rotational forces. Solution 114-103 is an eigenvalue analysis that computes modes of the system at rest. Solution 414-110 is a complex modal analysis that's used for finding critical speeds and analyzing the stability of the rotating system. Solution 414-111, a harmonic analysis for frequency-dependent excitation. And finally, Solution 414-129, transient analysis. In this example, we've performed a Solution 414-110 complex modal analysis. If we take a look inside of our options, we can see a new dialog box for writing the rotor D card. The user can specify the rotor speed variation type, either constant, linear by steps, or a function of our sweeping parameter. Then the user can specify up to 10 rotors by selecting their rotor regions. They can also apply a speed multiplier, either in the form of a function of the sweeping parameter or a constant value. The results data for rotor dynamics is stored to a file written in the HDF5 format, which is specific to Siemens products, the SCD5. For 2306, Femap is able to interact with the SCD5 file generated by Solution 414 to create both output sets and vectors, and also Femap functions to be used in post-processing. We can take a look at our functions and easily make a Campbell diagram. From the Campbell diagram, we can identify the critical speeds by looking at the intersection between the eigenfrequencies and the 2p line for a model that was evaluated in the rotating reference frame. Finally, we can perform some post-processing on the rotation speed at 12,000 RPM.